All right, so it seems that most of you are here already. So do you guys have a question or clarification so far?
Wala pa naman.
Wala pa.
Yan,
All right.
sir.
Okay, then that's good. How about the others? Wala pa up to this point? All right then. So if you guys do not have a question anymore, then let's now proceed to the next one, which is your seat break. So in here, find the negation of each. So there's a total of 5 questions. Okay, or 5 statements with quantifiers. Okay, so just negate all of those. All right. So use also Microsoft Word to answer this one. Okay. So when it comes to symbols, so just find the symbols here, go to insert, and then equation. Click nyo na equation and then magpapakita na to. Yung mga symbols natin sa taas. Right? So I think medyo kompleto naman siya kahit pa paano. So meron tayong not equal, greater than or equal, or less than or equal, etc. etc. Okay? So any concerns so far in your seat break?
Wala naman, sir.
All right. Next, we have here proofs. So what is this proof? It is an argument that establishes the truth of a theorem. So in other words, it's an argument from hypothesis to a conclusion. So we have here a proof derivation wherein we have equivalence rules, meaning it describes the logical equivalences. And then the next one is via inferencing rules or deductive, meaning it can describe when a weaker statement can be deduced from a stronger statement. So in this proof, we have here hypothesis. We have 2 parts. We have the hypothesis and then the conclusion. And then we have equivalence rules, wherein this hypothesis and conclusion can be derived into another kind of formula using the laws of logic or the logical equivalences. Okay, so what are those equivalence examples? So we have here the equivalence rules. So from here, okay, so lahat ng may mga equals, lahat sila logically equivalence. Okay, so we have here P is equal to not P, and then P conditional Q is equal to not P or Q. So itong implication, negation ni Morgan's law, commutative, associative. So lahat naman to nang galing. Okay? Nang galing to lahat sa laws of logic natin. Okay? So if you know our laws of logic, then you'll not be having a hard time in finding an equivalence for that kind of statement. Okay? And then the next one is inference rules or deductive, okay, wherein we will deduce that one into single variable. Okay. So let's say you have 5 variables. We will deduce that one into 1 or pwedeng into 2. Okay, but mostly 1. Okay. So first of all, you have to know this one before you can deduce such thing. Okay. So we have these rules of inference. It is to prove the theorem means to show that the implication is a tautology. And then take note when it comes to inferencing or when it comes to deducing such statements, the result should be always a tautology. Okay, so we have this kind of example: Pn, P conditional Q, conditional Q. So in this statement, we can actually deduce that one into a single variable. Okay, so this could be written as Pn, P conditional Q is equal to or concluded as Q. Right? So this one is called inferencing. Okay, so we have here the hypothesis. Okay, so you have 2 hypotheses, this one and then P conditional Q, which is equal to your conclusion Q. Okay, wherein the result of this statement is always a tautology. Okay? So we have here a proof using a truth table. Okay? So the first one is P conditional Q, wherein it just evaluated from these two possible outcomes. So true, true is true, true, false is false, false, true is true, and then false, false is true. Okay? So I hope familiar na kayo sa truth table ng conditional natin. So the only time that it will become false if we have a conclusion which is false, and then you have a hypothesis which is true. Okay? So kapag false tong conclusion, para maging true yung result, dapat false din yung hypothesis. Okay? So that's it for conditional. And then we have here and. So in here, our A is representing this P conditional Q. Okay, para hindi na masyadong mahaba yung ilalagay mo dito, or para hindi mo na kumpletuhin to. Okay, you can actually replace this one into a single variable, which is letter A. So in here we have P and A. So P and then A. So the first column and then the third column only. So true, true is true. True, false is false. False, true is false. And then false, true is false. And then lastly, this one now is our letter B, okay, which is now concluded as our Q. Okay. So true conditional true is true. False conditional false is true. False conditional true is true. False conditional false is true. Wherein our result is a tautology. So again, a tautology. So all of the result is true. Medyo nag-gets nyo ba so far?
Yes, sir.
Okay. So, siguro medyo nalilito pa kayo, pero magkakaroon tayo ng mga maraming examples mamaya. So, malalaman nyo kung paano naging Q na lang yung sagot natin dito. Okay. So, we have here inference form. So, again, the upper part is our hypothesis or premises. So, kahit ilan pa yan. Okay. And then, the last one is our conclusion, which is always a single variable. Okay. So, you can read this one as P1 and P2 and so on and so forth hanggang kahit ilan man yan. Okay. Which is equal to Q. Okay, or concluded as Q. Okay. So here are the basic rules of inference. So we have here identity. So if your hypothesis P is true, then it will be always true. Okay, wala na magbabago doon. Kasi nga, true na siya. In-assume na natin na true na siya. Okay. So if P is true, then P will always be true. So another example is if Q is true, then Q will always be true. Okay. And then letter B, if R is false, then R will be always false. Okay. So basically, kung ano yung nakita natin sa hypothesis, then yun na yung parang result natin or conclusion natin. Okay. Kasi wala naman na tayong ibang basis. So later on, kapag meron pang isa na hypothesis dito which can affect this hypothesis, okay, then that's the time that we can have changes for our conclusion. But in here, since iisa lang hypothesis natin, then iisa lang din yung conclusion natin. Okay. So another rules for inferencing here is this one. If P is assumed to be true and Q is assumed to be true, then we could say that P and Q is true. Okay. So since wala namang naka-apekto wherein wala namang negative value, okay, walang negative na Q, walang negative na P, and in-assume na natin na lahat ng hypothesis natin is true, then you can simply write our hypothesis as it is, okay, which is P and Q. So that is for conjunction. So actually, lahat ng rows na magkakahiwalay, let's say P, Q, R, so you read that one as P and Q and R, such that P and Q and R. Okay, parang sinasabi lang niya kung paano basahin. Okay, itong klase ng inference form natin. So another example here is conjunctive simplification, wherein P and Q is true, we can simply write that this one is just P. Okay? Kasi nga, proven na true na tong statement na to. Okay? Or, if P and Q is true, then we can just simply write this one as Q. Okay? Kasi nga, true naman na entire statement natin. So you can either choose either of those two variables. Okay? So P will always be true and then Q will always be true. Okay? Kasi kapag false to, for example, false lang to, then we could not say that it is P. Okay? Kasi nga false na yung, or meron na tayong value mismo ng P. Okay? So, since wala namang sinabing false to, okay, wala ring sinabing false yung Q, then we can assume that this one is equal to P or equal to Q. Nakakasunod ba kayo so far? Or medyo nalilito?
Sir, medyo nalilito.
So, ganun talaga. Since first time nyo siguro makita tong ganitong klase ng way of inferencing things or deducing things. So, later on, maybe mas mahihiwagaan kayo kung bakit ganyan yung mga result nila. But for now, ito yung mga rules natin. Okay? Parang sabihin na natin ito yung mga formulas natin, okay, on how to solve such inferencing or on how to deduce such statement. Alright, so next one. If we have conjunction, we also have disjunction. So correction pala, conjunction to, may letter N, and then conjunctive, meron ding letter N dito. Okay? So next one is disjunction or simply or. If P is true, then P or Q will always be true. Okay? So as you can see right here, wala namang additional or wala namang other variable. Kasi regardless, okay, regardless of the value of Q, it will be always true. Wherein we could say that P or Q, assuming that P is always true. Okay? So sa Q, kahit anong value yan, pwedeng false, pwedeng true, still the same. As long as our P is true. Okay? Next one, disjunctive syllogism. Okay? So dito, mag-focus na ka dito, makinig na ka dito kasi ito yung isa sa mga key points kung paano nyo malalaman yung magiging final result nyo. So as you can see right here, we have a total of 3 variables and then reduced into one single variable. Okay? So our first hypothesis is it's P or Q, and then assuming that P or Q is true. Okay? So that is our first hypothesis. But on the second hypothesis, we have proven that P is not true. This one is actually false. So this one now is not P or Q. Okay? And then for us to be able to say that the entire statement or the entire hypothesis are true, so we should have a true value for Q. Okay? Kasi nga, napatunayan na natin na false yung P, so dapat yung Q natin is true. Okay? So that is why we put here Q. Did you guys get it so far? Or medyo magulo pa din?
Medyo, sir.
Medyo na. Okay? So in here, we have 2 hypotheses. So again, proven na true tong P or Q. Okay? So laging kapag may hypothesis, laging ina-assume natin na true yung nandun na. Okay? Regardless of the symbol. So in here, P or Q is true. Okay? And then another hypothesis came out wherein it is saying that Q is not really true. It is actually false. Okay? So if this is false, then P must be true. Okay? So that is why we call this one tautology. Okay? Inferencing wherein the result should be always a tautology. Kasi nga, hahanap tayo ng conclusion or ng way para yung result natin is always a true statement. So in here, we've proven that this one is false, then this one should be true. Okay? Alright? Gets? So far for this disjunctive syllogism?
Yes, sir. Nagot na po.
Okay. So next one, another rules for inferencing. We have here modus ponens, and then modus ponens. So modus ponens first. So again, take note din dito kasi medyo tricky rin siya. So we have here two hypotheses. Okay. One is just simply P, stating that P is true. And then another one is a conditional, wherein it is stating that P is conditional to Q. Okay. So as we all know, in conditional, if hypothesis is true, then your Q must be always true for us to say that that one is a true statement. Tama? Kasi kapag true ito, and then false yung Q, pag nilagay mo dito negated Q, then that is already incorrect. Okay? For us to have, all true in this hypothesis, then Q must be true, which is this one. Tama? So kung babalikan natin yung truth table ng P conditional Q, meron tayong itong false saka true. Okay? So pag meron ka ng false na hypothesis, tama ba? False ba yun? Wala. So simply P and Q lang. Okay. Dito pala tayo. So true. Pag meron ka hypothesis na true and then a conclusion na true, so true na rin yung magiging result. So kapag binago mo to into false, false na yung magiging entire statement natin. Okay, so take note, in rules of inferencing, dapat true yung result. Okay, so that is why, so in this case, Q is our final result, or true Q, rather. So in Latin word, this one is called the affirmative mode. Okay, so another example of this kind of modus ponens. So we have here not P, conditional Q. Okay, so assuming that this is true. Okay, and then another hypothesis came out wherein, yes, this one is really true, not P. So if we have this kind of statement, then our Q must be always true. Okay, which is letter Q. Well, actually, pwede mong ilagay dito na not Q kasi nga false, conditional false is still true. But mauuna lagi yung non-changes natin. Okay? So if possible, kapag wala namang changes na gagawin or hindi naman kailangan and then true pa rin yung result, then wag mo nang palitan. Pero kapag necessary yung changes or yung from true, it will become negated value. So do it. Pero kapag hindi naman na kailangan, like for example, this one, false conditional true is still true, then just put here Q. Okay? Next one is modus tollens, wherein P conditional Q, and then our conclusion is assumed to be false. So kapag ganito yung result, okay, para kasi itong denial. Kapag false na yung conclusion natin, dapat false din naman yung hypothesis natin. Okay? Kasi nga, inassume natin na true ito, pero parang na-deny siya. Okay? That's why we call this one denial. Okay? So we should also negate that one. Okay? So from positive P it will become negated P. Okay? So this one is only applicable for conditional. If ever that this one is already proven true and then another hypothesis came out wherein we are saying that this Q is not really true, so we have to negate our hypothesis also, which is not P. Okay, so the same with this one. Not R and then conditional S, and then we have proven that this S is not really true. So we have to change or we have to negate the hypothesis also. So from negative, it will become positive. Okay, so negation times negation will just simply cancel out or will become positive, which is letter R. Okay. So modus ponens, we have an assumption for your hypothesis, and then modus tollens is we have an assumption for your conclusion rather. Okay? Did you guys get this one so far?
Yes, sir.
Yes, sir.
Right. So next, we have here the summary of the inference rules. Okay. So for conjunction, we have here P and Q. And then for modus ponens, so if we have P conditional Q, so you just simply write there Q. And then for modus tollens, P conditional Q, and then we have proven that this conclusion is really negated or false, then we have to negate your hypothesis also. And then for end elimination or simplification, we have here P and Q, and oops, bakit parang kulang? Ay, tama pala. So P and Q, conditional P, and then another format here is P and Q, conditional Q. So parang ito ang nakita nyo yung condition na to, palitan nyo lang to ng ganito, ng bracket. Equal siya sa P or equal siya sa Q. Okay? The same with this one. So this P could be equal to P or Q, and then this Q could be equal to P or Q. Okay, so again, this conditional symbol can be replaced with this kind of bracket. Okay. All right. So that's it for meron pa pala. Sorry. Kala ko hanggang dun lang. So another one is hypothetical syllogism. So we have here P or Q, P conditional Q, and then Q conditional R. So ang pattern nyo dito sa hypothetical syllogism is you have two hypotheses, which is this one, P conditional Q and then Q conditional R. And then if ever nakakita kayo ng yung first hypothesis, yung conclusion natin is this variable Q, and then sa second hypothesis, naging hypothesis na siya. So from conclusion to hypothesis, and then ang final deciding factor na natin is R. Okay? So parang pag ganito, pwede nyo na siyang i-shortcut. Kumbaga, parang you can neglect, okay, the inner variables, okay, which is letter Q. So pwede nyo natanggalin yan, and then diretso na kayo dito sa P conditional R. Okay? So wala akong nakitang parang steps dito, pero na-prove to gamit ang truth table wherein you can actually neglect this one. So it's like, deducing these 4 variables into 2 variables. So ito yung simplest way. So you can disregard the letter Q and then just go on straight to P conditional R. Right? So that's it for hypothetical syllogism. And then for disjunctive syllogism, or simply called elimination, so we have here PRQ, and then P is actually not P. So we could just say that that one, or the Q, is 2. And the same for this one. So PRQ, and then Q is actually false. So P must be true. And then negated, conditional false. So again, kapag false na yung, or proven na false na yung conclusion natin, so you'll just simply negate your hypothesis, okay, which is now letter P. Okay. So we have here another example for inference. So use a truth table to prove the following. So we have here P, and then P conditional Q, which is equal to Q, which is also known as the modus ponens. Okay. So let S be the statement. So P n, which is 1, and then P conditional Q, and then this curly bracket or equal is simply the symbol of conditional. Okay. And then Q. So actually pwede nyo i-transform tong inference format na to into a simple expression like this one. And then from here, kapag in-evaluate mo to, dapat lahat ng result is tautology. Like this one. Okay? So, iiwanan ko na yung analysis part sa inyo. Okay? Kasi, nagmamadali tayo. And then, I think kayang-kaya nyo naman tong evaluate ng gamit yung sarili nyong knowledge. Okay? So, we have here conditional and then and only. Okay? So, you guys already know on how to evaluate truth tables. Right, so let's have an exercise. So prove that P conditional Q, not Q, is equal to not P. Okay. So all we need to know, all we need to do is apply the equivalence rules and then the inference rules that we have learned. So we have here the solution. So kunin nyo lang to, P conditional Q and then not Q, and then simply find, okay, a way on how to eliminate uh, or how to deduce such statements. So in here, P conditional Q became negated Q conditional negated P. So how did we come up with this one? So we've applied contrapositive. Okay? So applicable pa rin dito yung laws of logic. Okay? Actually, kapag nalaman nyo na yun, itong mga following na examples natin mamaya, sobrang dali na lang. Okay? Kapag familiar kayo or medyo memorize nyo yung laws of logic natin. Okay? So from here, not Q, condition not P, and then we have here not Q. So this is our first hypothesis, and then second hypothesis. So in here, we have proven that not Q is true, which is this one. So we could just simply write not. Okay? Or just by simply applying modus ponens. Okay? Did you guys get this one so far?
Yes, sir.
Yes, sir.
So in this part, okay, kapag sasagot kayo sa mga ganitong klase ng exercises or seat work na ibibigay ko mamaya, okay, so hindi nyo na siya magagamit sa or hindi nyo siya mailalagay sa Microsoft Word. Okay, kasi wala akong nakitang symbol na ganito and then kasi meron lang is yung opposite nito. Okay, bracket facing the right one. And then this one, wala akong nakitang bracket facing the left side. So gamit na lang kayo ng ball pen, saka ng papel, and then please write legibly, and then if possible, maganda sana yung light background lighting nyo para hindi masyadong malabo yung picture na kukuhanan nyo. Okay? Kasi kapag hindi ko mabasa, so it's either i-inform ko muna kayo or kapag wala ng time, so it's either isi-zero ko na lang. Okay? Kasi nga hindi ko mabasa yung solutions nyo. So if possible, dapat clear na clear yung solutions nyo para yun, ma-check ko ng tama. Alright? So next example, you have here 1.1, prove that P or Q and R conditional not Q is equal to P. Okay? So from here, P or Q, wala siyang ginalaw. Okay? Ang ginalaw niya muna is ito, R, and then R conditional not Q. Alright? So dito muna tayo. So in here, we've applied modus ponens. Okay? So we've proven that R is really true. So we could just simply write not Q. Okay? And then for P or Q, and then not Q. So in here, we've proven that this Q is actually false, then P must be true. Gets nyo so far? So we have here the reference, which also came from our past inferencing rule or rules of inference. So eto muna, itong nasa baba, bago eto, nasa taas, to come up with letter P. Okay? So I'll give you guys a minute to analyze this one, and then let me know once it's already clear to you. So another way or another tips pala na masasabi ko is huwag nyo siyang ililiteral. Do not take it literally, okay? Like for example, this one is true and then this one is false. And then if you're going to evaluate this one, true conditional false, the result is false. Okay? So maybe baka baguhin nyo to into positive Q. So hindi siya ganun. Kapag meron na siya sa hypothesis or kapag given na siyang ganyan, this statement is already true. So assuming that R is true and then negated Q is true, so parang ganun yung values nila. True, true. Okay? So saka lang sila mababago. Okay? Saka lang sila mababago kapag merong ibang hypothesis na nag-prove na say this variable is really false or this variable is really false. Okay? So in here, R is true, then negated Q must be also true. So that is why we put here not Q. Sino nakagets? Wala pa ba? So can I know kung sino yung mga naguguluhan? Oh, walang sumagot So meaning all of you get it? Did you guys understood this one? Example 1.1?
Sir, paulit.
Sa
Medyo naguluhan lang, sir. So yung buo, sir, medyo naguluhan ako.
How about this one?
Sir, dyan okay naman na dyan.
Okay, so for example number 2 or 1.1, so we have here this inference format wherein we have P or Q and R conditional at Q is equal to, okay? So the first step that you need to do is just write or just copy your hypothesis as it is. So baba nyo lang siya dito, ito na yon. And then, hanap kayo ngayon ng mga statements na meron magkakaparehas na variable. Wherein, in our second row and then third row, meron tayong magkaparehas. So, letter R. So, pwedeng dito muna kayo tumingin. So, R conditional Q is true. And then we have another variable which is saying that R is really true. So, from here, we could conclude that since R is true, then not Q is also true. So saan nanggaling to? Okay, so paano na-solve to? Gamit itong formula na to. Okay, so modus ponens. Yeah, modus ponens. Oops, hindi pala. Ito. Hindi ito. Okay, ito nasa taas. So P conditional Q is true and P is already true. So Q must be also true. So copy nyo lang to, Q. And then dito rin, so proven na true na tong negated Q. So copy nyo lang din yan as it is. So no changes. Not Q. And then once you're done with this one, so again, hanap ulit kayo ng ibang variables na medyo ay may kaparehas. Okay? Wherein we have this Q and then not Q. So from here, you can take this one first. So P or Q. And then let's say assuming that this one is already true. Okay? And then another hypothesis came out wherein it is saying that Q is actually false, not Q. Okay? So para masabi natin true yung entire statement natin, P must be true. Okay? So parang lang iniisip nyo lang, dapat yung result nyo or dapat yung conclusion nyo will make the entire statement true. Okay? Pero in some scenario, okay, medyo nakakalito siya lalo na dito sa modus ponens and modus tollens. Kasi kapag tinake mo siya literally, like this not you, make this one false, then having a true conditional to false will make that one false. Okay. Pero dito kasi, everything, okay, kahit ano man yung mga symbols nila, negated man or hindi, lahat yan is true at first.